Hi, geometry students. Today we're going to talk about congruent triangles, starting a new chapter, chapter 4. So the first thing, what I would like you to do is just to look and see whether the green triangles are an isometry of the blue triangles by a flip, slide, turn, or none. So starting with the first problem, this one, decide whether it's an isometry. Yes, because it's a flip, so therefore we call that a flip. This one right here would be a turn. And notice that these are the same shape, or they're turning, but they're not changing anything. This right here would be a slide. And that would also be an isometry because we're not changing the size of the shape, but we are just sliding it. But this one, which is none of them, if you look at this, these are dilations. So therefore, you would say no, it's not isometry. TRY. Anyway, so this section is basically about congruent figures. So whether or not two shapes are congruent, in this case, these triangles are congruent. The informal definition states that congruent figures have the same size and the same shape. So it doesn't matter if they're turned or not. If they have the same size and shape, then they are congruent. The formal definition states that two polygons are congruent if and only if all the corresponding angles and all the corresponding sides are congruent, meaning they have the same size and the same shape. Congruent figures, in this case right here, if you know that a triangle ABC is congruent to triangle DEF, then you would say that those 6 parts of the first triangle are congruent to the 6 parts of the second triangle, as long as they're corresponding. So basically I could say, let's see, for this triangle here, I would say that angle A is congruent to angle, and see how this is set up, ABC and then DEF? Angle A is going to be congruent to angle D. See how they're corresponding? A corresponds with D. Even though the triangles are turned, they correspond in the writing. So we know that angle A is congruent to angle D. We know that angle B is congruent to angle E. And so this, you would show that that's congruent with 2 little slashes. And then you have angle E here. And then you would say angle C is congruent to angle F. So this here, 1, 2, 3, would be congruent to 1, 2, 3. In addition to those 3 angles, you also know that the sides are congruent. Now, the way you say the sides, I mean, there's different ways to look at it. If you see this is 1 slash and this is 2, so in between 1 and 2, that's your AB, that would be congruent to DE. But another way of seeing that is, see here, AB is congruent to DE. See the 2 letters in the first and the second? So you can say AB is congruent to segment DE. You can also say segment BC is congruent to segment EF. One last one would be CA. So you can say CA is congruent to, let's see here, CA, FD. Okay? So those are my 3 angles and 3 sides that are congruent. So without drawing a picture, list all the congruent parts. We don't have to draw a picture. We could, but we don't have to. So we know, just looking at the words, that triangle FAR, we know that angle F is congruent to angle B. We know that angle A is congruent to angle I. If you see in the middle, here's A, here's I. Angle R is congruent to angle G. You also know FA, so line segment FA, is congruent to line segment BI. You know that line segment AR is congruent to line segment IG. And you also know that RF, line segment, is congruent to line segment GB. So what you can do, so here in this problem right here, you have triangle SUN, so SUN and it's congruent to ROA-Y. So notice the way I write SU left N. So we're going to call this R left A Y. List 5 other ways to write the congruence. Well, one way is just to say, instead of starting with S and going SUN, I could say SNU. So SNU is congruent to triangle RYA. I could say triangle USN is congruent to triangle ARY. I can say triangle UN and start that way. Oops. I can say UN. So UNS is congruent to triangle AYR. I can say triangle NSU is congruent to triangle YRA. And I can say triangle NUS is congruent to triangle YAR. So you have a lot of options on how you write these, but they all mean that they're congruent. So the big picture item here is that the two triangles are congruent if all of their parts are congruent, but also if you have two triangles congruent, then all their parts are congruent. So let's see, going on. Okay, so when using the definition of congruent triangles, this is a big important proof, and you would say corresponding parts of congruent triangles are congruent, or CPCTC as shorthand. So corresponding parts of congruent triangles are congruent. So if I know that the triangles are congruent, then all of their parts are congruent. And you would say that in a proof, triangle ABC is congruent to DEF. That would be your statement. You know A is congruent to D, and the reason would be because CPCTC. And then you got to practice saying that, CPCTC. Corresponding parts of congruent triangles are congruent. And they're just saying that once I have these two triangles congruent to each other, then all of their parts are congruent. So guiding question, what information about the two triangles is enough? Well, basically, you need to know several things about two triangles to prove they're congruent. You have to have a minimum amount of information. Some things, for example, I could say the side is congruent to this side, but that doesn't mean they're congruent. I could say this angle is congruent to this angle here, but that doesn't mean the two triangles are congruent. So like what makes two triangles congruent? You have to have a minimum, a bit of information. These two, just like that, these two triangles would not be congruent. However, if I added an angle in here and I said that angle is congruent to this angle here, then I would have an angle congruent to an angle, another angle congruent to another angle, and a side congruent to a side. We actually have a name for that. We call that angle, angle, side. That actually is enough information to prove these two triangles congruent. So there's actually 5 ways to prove two triangles congruent. So there's 5 ways to do that. And so we're going to talk about all 5 of those ways. This is just one of those ways. So the first way is what we call side, side, side. If you have a side congruent to a side of the other triangle, another side congruent to another side, and a third side congruent to a third side of the other triangle, if you have all of this information, we call that side, 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 then those two triangles are congruent. The next way to prove two triangles are congruent is what we call side, angle, side. Side, angle, side. And that means that you have to have a side congruent to a corresponding side. Notice where the angle is. This is really important, that angle has to be in between the two sides. You notice that? The angle is in between. So you have a side congruent to a side. You can go this way and say, well, that angle here is congruent to that angle. And then you also know that this side here is congruent to this side. If you have those 3 bits of information, a side, an angle, and a side, notice that my angle, so the angle has to be in between the two sides. So if you have that, that's called side, angle, side. you notice you could also prove two triangles congruent. And you could also say like this side is congruent to this side, and then you have like that angle congruent to that angle, that side congruent to that side. Then those also would be congruent. The same triangle would be congruent just by a different method. So that's 2. Number 3 is what we call angle side angle. We call angle congruent to angle here. You have a side in between the two angles. So if I say angle, then the next thing has to be a side congruent to a side. So angle, side, and then here is another angle congruent to an angle. Okay, so that's what we call angle, side, angle. Keep in mind, I mean, you can always do different, watch, you could say, I could say this angle here congruent to this angle, this side congruent to this side, and then this angle here congruent to this angle here. That's also angle, side, angle. Now, this one, if you notice, we already talked about this in the beginning. This is called angle, angle, side. I can have an angle congruent to an angle. I have another angle congruent to another angle, and then a side congruent to a side. Notice that my side is not in between my two angles. We call that angle, angle, side. Okay, so far that's 4. There's another one which we call HL, which is called hypotenuse leg. For you to have a hypotenuse leg, there's certain conditions that have to happen. Number 1, you have to have a right angle. Okay, this is a special case because see, side angle or angle side, we actually don't use that. It does not guarantee triangles are congruent. So anytime you see a side angle, not happening. Okay, that's not going to be it's not allowed to make the two triangles congruent. Remember, the only ones that work, that does not work, all right, is you could have side, you could have side, angle, side, angle, and angle, side. And then the last one, of course, is hypotenuse leg. So in order to have a hypotenuse, you actually need a right angle. So remember, the hypotenuse is opposite the right angle, okay? And you need a leg. So here's a leg and here's a leg. Now, those are the legs of a triangle. If you remember, to have a right triangle, okay, a right triangle, there's your right angle. This is your hypotenuse, which is always opposite. The hypotenuse is always opposite the right angle. And then you have two legs. Here's a leg and here's a leg. If this leg is congruent to the other leg, they have to be corresponding. You can't use one leg up here and one leg down here. You have to be corresponding. So you've got your hypotenuse in a leg, and it could have been hypotenuse in that leg and hypotenuse in that leg. Some conditions are you have to have two right triangles. Okay, so that's one of my conditions. The triangles have to have congruent hypotenuses, so these have to be congruent. And there has to be one pair of congruent legs, and they have to be corresponding. You can't just say the top, meaning, let me show you what you can't have. So if I redrew two right triangles that I'm going to say may or may not be congruent, I would definitely say, well, here's my hypotenuse, congruent to my hypotenuse, check. But I cannot say this leg here is congruent to this leg here, because you can't say that. They have to be corresponding. So this would be not happening, okay? That would not be allowed. So the 5 ways of proving two triangles congruent are side, angle, side, angle, angle, side, and hypotenuse leg. And that's only with right triangles. So practicing. Complete the congruent. So what we're going to do is we're going to say why these two triangles would be congruent. So we're going to give the reason, and then we're going to state the order of how we would say the two triangles are congruent. So for the first problem here, this one, you're going to see we have a side congruent to a side. This side happens to be my hypotenuse. Do you notice that? But for me to use hypotenuse leg, I would actually need a leg, which I don't have. What I do have is this angle congruent to this angle by vertical angle theorem. So what I have is angle, angle, side, congruent to angle, angle, side. So the reason that the two triangles are congruent is angle, angle, side. And I would say ABC. Now, it's actually, you would get this wrong on a test if you said this wrong. If I said A, B, so, and I always like mark it, A going that way, B. So I've got right angle going to the opposite B. So right angle, so D. So the next one will be triangle starting at D, and then I'm going that way to get E, and then what's left is the C. All right. For this example right here, I have to use one of my options. Remember, I have 5 ways to prove two triangles congruent. Notice that FG is congruent to itself because that's the reflexive property. So what I have is a side congruent to a side congruent to a side, and a third side congruent to itself. So this is what we call side, side, side. And so therefore, F, go left, H, G is going to be congruent to F, I, G. Okay? The next one is, I know this is congruent to itself. AB is equal to itself because, you know, if you were to split up both of those triangles, you've got that one line in both triangles. So it has to be the same line. It's congruent to itself. We have a side congruent to a side. We have an angle congruent to an angle. And this looks like it's angle, side, side, or, please don't say that, side, side, angle. Now, side, side, angle is not a method for proving two triangles congruent. So for this one, you would say no congruence. For this one, let's see, we know that OP is equal to itself because, again, that's by the reflexive property. We know that's a right angle, therefore that must be a right angle. Let's see, so it looks like actually we have a hypotenuse and a leg congruent to a hypotenuse and a leg. So this is going to be congruent by HL. And triangle Q, Q, they're starting down here, QOP is congruent to ROP. And remember, it's just as important as getting the method that they're congruent as it is to say the reason that the two triangles are congruent. For this one right here, again, see this SU? I know that that's congruent to itself. And therefore, we have side, angle, side, side, angle, side. So this would be, these two triangles would be congruent by side, angle, side. And again, you need to label it correctly. So it'll be triangle STU congruent to SVU. So SVU. Okay. For this one, this is congruent to itself. We have a hypotenuse congruent to a hypotenuse. Notice it's a right triangle. So we have hypotenuse and leg congruent to hypotenuse and leg. So this is HL again. And triangle WYX is congruent to triangle WYZ. For this one, looking an angle congruent to an angle, a side congruent to a side, and actually I have this angle congruent to this angle by the vertical angle theorem. So now these two triangles are congruent by angle, side, angle, and therefore triangle JMN is congruent to KML. For this one, of course, we know this angle in here is congruent to that angle in there, but I don't have any sides. And if you notice all the ways, we've got side, angle, side, angle, we have angle, angle, side, we have, what am I missing? Side, 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 and I have HL, 1, 2, 3, 4, 5. And basically, if you look at every single one of these, there's a leg or a side in them, not just angles. And so therefore, these two triangles aren't congruent. So this one would be no congruence found. So there's no congruence there. And the last one, parallel lines. So we've got a side congruent to a side. We actually have an angle congruent to an angle by the vertical angle theorem. But because these two lines are parallel, this gives me this angle and this angle congruent. Let me put 2 slashes there. And this one has 2 slashes because those are alternate interior angles. And also this angle here is congruent to this angle here. So you have options on this one. This is either angle, side, angle. So I can say angle, side, angle, congruent to angle, side, angle. Or I could say angle, angle, side. Or I could say angle, angle, side. And so JKL is J over K. Notice how I got J here moving this way, KL. So this would mean that I've got the, what is this? It looks like between the 3 and 2. So this started with the 2 to 3, no, M to N. So that would be M, N, L. Okay, cool. So we have a proof. And so let's start it. E is the midpoint of MJ. So that right off the bat, here we go. I'm trying to prove this triangle is congruent to this triangle. So in doing that, we know E is the midpoint. Well, if E is the midpoint of MJ, that cuts these two into two parts, right? So right off the bat, why did they tell me that E is the midpoint? They told me that because ME is congruent to EJ. I know that right off the bat because definition of a midpoint. Okay, what else do we have in our given? We know that TE is perpendicular to MJ, so there's a right angle here, okay? Well, that's given. Okay, and by the way, this would be 1 for definition of a midpoint for my reason. Number 3, let's see what we know. We know that also TE is congruent to itself. I'm not sure if that's going to help us at this point, but that's reflexive property of congruence. All right. And then in addition to that, let's see, so let me put that in here. Anytime you get new information, you should always draw it on your picture. So to me, it actually looks like if these lines are perpendicular, then those are going to form right angles. And if perpendicular lines form right angles, then those are going to be congruent. So I can actually say for step number 4 that TEM, angle TEM is congruent to angle TEJ. And the reason is perpendicular lines form congruent adjacent angles. Okay? And therefore, if these two angles are congruent, even though they're right, they're still congruent, I know that these two triangles are congruent by side angle side. So I can actually say MET is congruent to JET by side angle side. Okay? So for the next one, we know that for the next proof, you know that AB is parallel to DC. Okay, now remember, why did they tell us that? Well, parallel lines form congruent alternate interior angles. That's why they said that. So we know that because of this one statement right here, that then this angle here is congruent to this angle here because those are alternate interior. So right from the start, I can say angle DCA is congruent to angle BAC because parallel lines form congruent alternate interior angles. Congruent. Okay. Also, we know that AD is parallel. So we also know this is parallel to this line right here. So parallel lines also those parallel lines form congruent angles that are adjacent. So those angles in here are also congruent. So this right here is based on number 1 and number 3, because what they said for, oh, I should write given here. AD being parallel to BC, that gives me angle DAC congruent to angle BCA. There we go. BCA, and the reason for that is also alternate interior angles are congruent. Well, in addition to all of that information, we know that this line is congruent to itself. So we also know that AC is congruent to AC, and that's by the reflexive property of congruence. All right, so now I actually have enough information. I can prove these two triangles congruent because I have an angle congruent to an angle. I have a side congruent to a side. See, this side happens to be in both triangles. If I were to split these two triangles apart, that one side would be in both. And then I have an angle congruent to an angle. So I can say that triangle ABC is congruent to triangle CDA 5 by angle, side, angle. Now, I just want to talk to you about this real quick because I know that once my triangles are congruent, if my two triangles are congruent, we talked about this in the beginning of the lesson, then all of the parts are also congruent. So if my two triangles are congruent, then the parts are congruent. So I could actually say now, where the proof is over, but I'm just saying, I could even say angle D is congruent to angle B. I could say AD, line segment AD, is congruent to line segment BC. I could say AB, line segment AB, is congruent to line segment DC. I could say any of those, and the reason is because of CPCTC, because corresponding parts, these are the corresponding parts of congruent triangles. This means that they're already congruent, are congruent. So if the corresponding parts, if the two triangles are congruent, then all of the parts are congruent. Okay? So I hope that helps, and I'll see you next time. Thanks.